Hello, welcome back. Same question, different method. So there are 3 red counters, 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. We have to work out the probability that he takes exactly 1 red counter. In the previous episode, we deal with this question using direct probability, the use of the law of or and and. That's combination of probability terms. Now here we want to use the combination itself. You can see there are series of combination here. The first combination is picking 3 out of a total of 8. We want to pick. Where is it? We are picking at random 3 counters from the bag, which will be containing 3 and what? 5, which is total of 8. So the probability of picking, or the combination, let me begin with combination. The combination of picking 3 from a total of 8 will be written as 8 here, combination 3. Meaning from total, we are picking 3, which we know can be written as 8 factorial over 3 factorial minus 8 minus 3 all factorial. I guess remember the factorial expansion, whereby we multiply the numbers from itself down to 1. Series of multiplication for the number down to 1. Alright, this is going to be a subtraction, and that will give us 8 factorial divided by 3 factorial 5 factorial. So this is the selection of 3 out of a total of 8. That is 1. Alright, in the second instance is that we are looking out for selection exactly 1 red. And that 1 red will be taken from a pool of what? 3 reds in a bag of in a bag that contains counters. We have a total of 3 red. So if the chance that I pick 1 out of the 3 selection, I am picking it from the total of 3. So I will be having 3 combination 1, meaning from the pool of 3, I am picking only 1. And if I am picking only 1, it means that I will be left with 2. I am picking 3, total of 3, not from here. 3 is representing the total in red. This 3 is representing the number of counters I will pick, which some will be yellow, some will be red, because I need only exactly 1 to be red. So it means that after picking this, I'll also be picking from 5, picking 2. This is representing red. I am picking exactly 1 red from a total of 3. But I need 3 counters at last. So it means that after picking 1, I'll also be left with 2 to pick. And that 2 be coming from the pool of what? Yellow. I guess you get it. It will be 2 from the yellow side, 1 from the red side. So this and this, not all, this and this. Either this comes first before this is a multiplication. So we can still expand that to have 3 factorial divided by 1 factorial into bracket 3 minus 1 all factorial times 5 factorial divided by 2 factorial into bracket 5 minus 2 all factorial. So let's simplify this also and see. That is going to be, okay, let's take the first one. Here, I will still have my 3 factorial in the denominator. 1 factorial is 1, so I can ignore that. This becomes 2 here, because 3 minus 1 will give us 2. That will be 2 factorial times 5 factorial. In the case of this, I will still have the 2 factorial. Then 5 minus 2 will be 3. So 3 factorial. But you can see from here that numerator, denominator, it will cancel. So I'll be left with only 5 factorial in the numerator. Then the denominator will be 2 factorial times 2 factorial. I guess you get that? This 3 is cancelling this. Even if I expand it, they will still cancel themselves because it's going to be 3 times 2 times 1, 6. 3 times 2 times 1, 6. 6 divided by 6 will still cancel out. Now, what are we doing? This is the selection, the 3 selection. This is the total selection. So, the probability of selecting exactly one red will just be the probability of the selection over total number, right? The combination. This is the combination of selecting exactly one red. This is the combination of selecting 3 from a pool of 8. So that will be the event 5 factorial over 2 factorial, 2 factorial divided by 8 factorial divided by 3 factorial, 5 factorial. This can be expanded in real times. This is going to be 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1. So let's just put them together and see. So our numerator will be giving us 30. Our denominator in the case of this will be giving us 56. So let's see, if I have 56 divided by 2, what will I get? That will be 28. The top will be 15, then 28. So therefore, probability of selecting a one red will be 15 out of what? 28. You remember the first example, the first method, we also arrive at 15 out of what? 28. So either you use the combination approach or we use the direct probability approach, your solution will still remain the same. Thanks for watching. Share with somebody, like, comment, and subscribe. Bye-bye.